In computer science, the Boolean or logical data type is a data type, having two values, intended to represent the truth values of logic and Boolean algebra. It is named after George Boole, who first defined an algebraic system of logic in the mid-19th century. The Boolean data type is the primary result of conditional statements, which allow different actions and change control flow depending on whether a programmer-specified Boolean condition evaluates to true or false. Generalities: in programming languages that have a built-in Boolean data type, such as Pascal and Java, the comparison operators such as and a permil are usually defined to return a Boolean value. Conditional and iterative commands may be defined to test Boolean-valued expressions. Languages without an explicit Boolean data type, like C90 and Lisp, may still represent truth values by some other data type. Lisp uses an empty list for false, and any other value for true. C uses an integer type, where relational expressions like I, J and logical expressions connected by and are defined to have value 1 if true and 0 if false, whereas the test parts of if, while, for, etc., treat any non-zero value as true. Indeed, a Boolean variable may be regarded as a numerical variable with a single binary digit, which can store only two values. It is worth noting that the implementation of Booleans in computers are most likely represented as a full word, rather than a bit. This is usually due to the ways computers transfer blocks of information. Most programming languages, even those that do not have an explicit Boolean type, have support for Boolean algebraic operations such as conjunction, disjunction, equivalence, exclusive or non-equivalence, and negation. In some languages, like Ruby, Smalltalk, and Alice, the true and false values belong to separate classes. For example, true and false, resp. so there is no single Boolean type. In SQL, which uses a three-valued logic for explicit comparisons because of his special treatment of nulls, the Boolean data type is also defined to include more than two truth values, so that SQL Booleans can store all logical values resulting from the evaluation of predicates in SQL. A column of Boolean type can also be restricted to just true and false though. In the lambda calculus model of computing, Boolean values can be represented as Church Booleans. ALGOL, Java, and C, one of the earliest programming languages to provide an explicit Boolean data type, was ALGOL 60 with values true and false and logical operators denoted by symbols, and. Due to input device limitations of the time, however, most compilers used alternative representations for the latter, such as and or and. This approach was adopted by many later programming languages, such as ALGOL 68, Java, and C. Fortran, the first version of Fortran and its successor Fortran 2 did not have logical values or operations. Even the conditional if statement took an arithmetic expression and branched at one of three locations according to its sign. See arithmetic if. Fortran 4, however, followed the ALGOL 60 example by providing a Boolean data type, truth literals, Boolean-valued numeric comparison operators, and logical operators. In format statements, a specific control character was provided for the parsing or formatting of logical values. Lisp and Scheme, the Lisp language never had a built-in Boolean data type. Instead, conditional constructs like condition assume that the logical value false is represented by the empty list, which is defined to be the same as the special atom nil or nil. Whereas any other S expression is interpreted as true. For convenience, most modern dialects of Lisp predefine the atom T to have value T, so that one can use T as a mnemonic notation for true. This approach was retained in most Lisp dialects, and similar models were adopted by many scripting languages, even ones that do have a distinct Boolean type or Boolean values. Although which values are interpreted as false, and which are true vary from language to language. In Scheme, for example, the false value is an atom distinct from the empty list, so the latter is interpreted as true. Pascal, Ada, and Haskell, the Pascal language introduced the concept of programmer-defined enumerated types. A built-in Boolean data type was then provided as a predefined enumerated type with values false and true. By definition, all comparisons, logical operations, and conditional statements applied to and or yielded Boolean values. Otherwise, the Boolean type had all the facilities which were available for enumerated types in general, such as ordering and use as indices. On the other hand, the conversion between Booleans and integers still required explicit tests or function calls, as in ALGOL 60. This approach was adopted by most later languages which had enumerated types, such as Modular, Ada and Haskell. C, C++, Objective-C, Awk, Perl, the initial implementations of the C language provided no Boolean type, and to this day Boolean values are commonly represented by integers in C programs. The comparison operators are defined to return a signed integer result, either 0 or 1. Logical operators and condition testing statements assume that 0 is false and all other values are true. One problem with this approach is that the tests if t true and if t are not equivalent. After enumerated types were added to the ANSI version of C, many C programmers got used to defining their own Boolean types as such, for readability reasons. However, enumerated types are equivalent to integers according to the language standards. So the effective identity between Booleans and integers is still valid for C programs. Standard C and several dialects of C such as Objective-C provide definitions of a Boolean type as an integer type and macros for false and true as 0 and 1, respectively. Thus logical values can be stored in integer variables, and used anywhere integers would be valid, including in indexing, arithmetic, parsing, and formatting. This approach has been retained in all later versions of C. C++ has a separate Boolean data type, but with automatic conversions from scalar and pointer values that are very similar to those of C. This approach was adopted also by many later languages, especially by some scripting ones such as Awk. Objective-C also has a separate Boolean data type, with possible values being yes or no, equivalents of true and false respectively. Perl has many values of false, the number 0, the strings 0, and the empty list, and a special value unv. Everything else evaluates to true. Python, Ruby, and JavaScript. In Python from version 2.3 forward, there is a bool type which is a subclass of int, the standard integer type. It has two possible values, true and false, which are special versions of 1 and 0 respectively and behave as such in arithmetic contexts. In addition, a numeric value of 0, the null value, the empty string, and empty containers are considered Boolean false. All other values are considered Boolean true by default. Classes can define how their instances are treated in a Boolean context through the special method non-zero or bool. For containers, len is used if the explicit Boolean conversion method is not defined. In Ruby, on the other hand, only nil and a special false object are false, everything else is true. In JavaScript, the empty string, null, undefined, nan, plus 0, a 0 and false are sometimes called falsy, and their complement, truthy, to distinguish between strictly type-checked and coerced Booleans. Languages such as PHP also use this approach. SQL, the SQL 1999 standard introduced a Boolean data type as an optional feature. When restricted by a not null constraint, a SQL Boolean behaves like Booleans in other languages. In SQL, however, the Boolean type is nullable by default like all other SQL data types, meaning it can have the special null value as well. Although the SQL standard defines three literals for the Boolean type true, false and unknown it also says that the null Boolean and unknown may be used interchangeably to mean exactly the same thing. This has caused some controversy because the identification subjects are known to the equality comparison rules for null. More precisely, unknown equals unknown is not true but unknown null. As of 2012, few major SQL systems implement the TO31 feature. PostgreSQL is a notable exception, although it does not implement the unknown literal. Null can be used instead. In other SQL implementations, various ad hoc solutions are used, like bit, byte, and character to simulate Boolean values. See also, true and false commands for shell scripting, Shannon's expansion, St. Boole H. Euro C. 99 Definitions for Boolean, references.